This talk is about interesting aspects of our solar system, maybe goes beyond the basic stuff, and probably you all know a lot about the solar system, but this touches on few aspects that I find very interesting. But as Bill suggested earlier, I should say few interesting things about myself. I have 3 citizenships. You probably met some dual citizens, but I have 3 of them: Turkish, Canadian, and proud to be American. I lived in 5 countries for extended periods, like 3+ years each: Turkey, Canada, Japan, United Kingdom, and United States, obviously. Visited more than 70 countries around the world, I think every continent except Antarctica, mostly for business, but some for vacation. I had 3 careers. I'm a computer scientist, worked on predecessor to internet. I was a telecom executive. I was a CTO of British Telecom in the UK. And I was an investment banker, raising funds and also working on mergers and acquisition of high-tech companies. And I retired after cancer diagnosis and bought myself this telescope that you see, Celestron 9.25-inch SCT. My interest in astronomy goes beyond observing. I love observing, obviously, but I'm also interested in what I'm observing and what I cannot observe. I just completed my 70th trip around the sun, which is about 41 billion miles. So I traveled quite a few billion miles around the sun already. Speaking of billions, our solar system, as you may know, is 4.6 billion years old. But our universe is, as you also know, is 13.8 billion years. And our Milky Way galaxy is 13.5. So our sun and our solar system is relatively young, with 4.6 billion. It was formed as a nebula first, a cold gas, dust, and so forth. Then it starts spinning and heating up, mostly hydrogen and helium. Under the influence of these gravity and spin, proto-sun was formed. So before the sun, we had proto-sun. The regions formed around this proto-sun and several irregularities in the spin. And that's how the planet symbols or the future planets were formed. The rocky planets were closer, and the gas giants and ice giants were further away. And there was a planet that failed to form between the future Mars and Jupiter, and that's how we got the belt of asteroids. And the radiation from the sun blew away most of the remaining gas, and we have, as a result, the Oort cloud of where most of the comets reside today. So there are, as you know very well, 8 planets, recognized officially planets. I don't know how many of you know how many moons we have, but I was surprised to learn that we have hundreds of moons, officially 140, but as you will discuss, the number of moons actually could be much higher. You know, we have the Mercury, Venus, Earth, and Mars as the rocky planets, the gas giants of Jupiter, Saturn, and ice giants of Uranus, Neptune. But what some people may not know is space that the planets cover is about 3.25 billion miles. That is minuscule compared to 9.3 trillion miles across for the total solar system. And that's the Oort cloud and so forth. Now, the sun is expected to last about 10 billion years. But in 5 billion years, we are expecting the hydrogen fuel to start to run out and become a red giant. and expand to cover all the way to Earth and Mars. So imagine the sun covering all the way to where Mars orbit is. All these planets are on an elliptic plane, as you probably know, and interestingly, all of them spin around or orbit around the sun in the same direction as the spin of the sun. And you could actually calculate the rotation, the orbital periods, if you know the distance from the sun based on or thanks to Kepler's three laws that I'm sure some of you, if not most of you, know. Sun is Jack studies sun very well, of course. It's currently at 71% hydrogen. The remaining is helium. It has three major zones. Core zone is where the nuclear fusion takes place. Radiation zone is about 300,000 kilometers wide. What I found interesting is it takes photons 1 million years to traverse this zone. I wonder what the reason was, and I read about this random walk that these photons pursue to traverse from the beginning and end of this radiation zone. The convection zone, slightly narrower, 200,000 kilometers, but the photons transfer here from the bottom to the top in 10 days. Because convection works, as you know, rising hot plasma and then going down, falling down cooling plasma. So it is a very efficient transmission of photons. But what some people may not know is that these radiation and convection zones are so critical for this hydrostatic equilibrium, and they prevent the sun from flying apart or burning its fuel too fast. So we thank these two zones to create the balance for sun to continue as our source of energy. I'm not going to spend too much time here, but in addition to core and radiation and convection zone, we have in the sun the photosphere, chromosphere, and corona. The interesting thing is corona is the largest one, the widest one, and the temperatures vary very interestingly. At the core, it could be up to 10 million. Then it goes down at photosphere down to 5.8 thousand centigrade. And at corona, it jumps to million degrees of centigrade. So this is, of course, the reason of the convection zone. And people like Jack probably know this much better than I do, but the temperature changes as the photons go from the core all the way to the corona and out. The magnetic field of the sun is the most interesting part. And the reason for some of this interest actually is the rotation speeds of the convection zone. It rotates at different speeds. At the equator, it is 25 days. At the poles, it is 34 days. And this phenomena creates the magnetic fields getting twisted. And this tangled magnetic field lines inhibit the flow of heat. And as a result, you have cooler spots, which is what we call sunspots, surrounded by warmer areas. And that's how the sunspots form. And you also have these magnetic eruptions in the form of flares and loops, especially these activities are tied to the cycle, and this minimum to maximum takes about 11 years or 22 years, I guess, for the complete cycle. We are in this solar cycle 25. Don't ask me why it is 25. Jack would know. And it is coming to the maximum, if I understand correctly, by July 25, 2025. So that means we have quite a few significant magnetic activities coming up in the next 3-4 years. Solar winds, quite important for us here on Earth, are basically charged particles, electrons, photons, and alpha particles. The interesting thing is, depending on where they originate, their intensity and speed varies. If they are coming from the equatorial zone, for example, they are slower but intense, more dense. If they are coming from the polar zone of the corona, then they are faster but less intense or less dense. If they reach the surface of Earth, they would definitely damage life forms here. But thanks to our own magnetic field, they are diverted to the poles, and we have the auroras and so forth. The first planet is Mercury. It is the smallest, closest planet. It is probably bombarded with meteors the most, and it does look like the moon in that sense. One thing that people may not know, and correct me if I'm wrong, if you guys all know this, I didn't, 3 Mercurian days are in 2 Mercurian years. In other words, it spins around in 59 days and goes around the sun in 88 days. So equation is 3 days in 2 years for Mercury. The other interesting thing about Mercury that I'm sure some of you know is that it has a comet tail. And this is partially due to the solar winds, and it's mostly made of sodium. And you could see this with your telescope. I failed to see it, but it is, I'm told, it is very easy if you are good at observing to see Mercury's. The problem, of course, with Mercury observing is it's so close to the sun, you have to watch it during the sunset or sunrise, and sometimes you are not as lucky. Other interesting thing about Mercury is that some of the surface features are named like Michelangelo, Dickens, and Beethoven, and I find that quite interesting. Venus is probably the most favorite planet for lots of people. It is identical to Earth in many aspects, but very different in many others. It has a cloud cover, unbroken cloud cover, dense cloud, permanently enveloping the planet. Similar to Mercury, since it is so close to the sun, Venusian day is longer than Venusian year, believe it or not. 224 days to go around the sun, but it takes 243 days to spin. So it spins very, very slowly, if you consider that a spin. So you have day longer than the year. Also, because of this very slow spin, there is almost no magnetic field because of the slow spin. The interesting that probably most of you don't know is that even though Venus has tectonic features similar to Earth, you know, in Earth case, earthquakes move sideways, the tectonic plates. In Venus, the Venus quakes, they move up and down like an elevator. So when there is a Venus quake, it goes up or down. The other interesting thing about Venus that you probably know is that it spins from east to west. So opposite of Earth in a sense. And sun rises in the west and sets in the east. And there is another planet like that, I'll mention it, but there are only 2 planets in our solar system that has this spinning from east to west. Venus atmosphere is most interesting part of Venus, actually. It's all carbon dioxide, multiple layers of the clouds. It makes it very bright, beautiful, and reason why it is called Venus. Even though 20% of the sunlight reaches the surface, it is very, very hot, 400 plus, 460 degrees centigrade. Recently, they found that there is a possibility of life in the clouds of Venus. And this image that you see here is a science fiction reflection of living in a cloud city on Venus. Earth. Now, what can I tell you about Earth that you don't know? I actually, I think you know everything about Earth, but what some people may not know is that 2% of our water is actually in the ice sheet and the glaciers. This, from the global warming point of view, the importance of how the glaciers and the ice sheets are important. 2% of our water is in those places. The other thing that I found interesting is that the biological and geological end of Earth comes in multiple steps. The oceans will boil in 1 billion years. Magnetosphere will decay in 2-3 billion years. We are going to extreme heat on the surface, the greenhouse effect, in 4 billion years. And in 7.5 billion years, well, that's when the red giant face of the sun will envelope Earth, together maybe with Mars. We probably don't need to worry about these things, but that's how the end of the Earth is projected, okay? The moon, I may know a few things that some of you may not know. So first of all, moon is moving away from Earth. Now, you may or may not know that, but it is about 1 inch per year, about 2-finger distance. In other words, 4 feet since the first man landed on the moon. The other interesting thing about this is that when moon was formed, the rotation around the Earth was about 8 hours. Today, it is 27 plus days. When moon was formed, it was rotating 8 hours rotating around Earth in 8 hours. And it was 20 times closer to Earth, about 400 times bigger in the sky, and 8,000 times more powerful in tides. Just imagine how much tidal effect that would mean. Now, you know, we are tidally locked to the moon. Another interesting thing that I learned is that the solar winds are replenishing the thin atmosphere around the moon. Even though it is escaping continuously, thanks to solar wind, there is always some minute amount of thin atmosphere around the moon. You probably know the formation of the moon based on a Mars-sized asteroid hitting Earth in the early formation. And there are actually multiple theories, but this is the most likely, I'm told. Mars has several similar things with Earth. It has about the same spin time, about 24.63 Earth hours, twice the length of the year. One Mars year is about 687 Earth days. The tilt is about similar, 25 degrees. The interesting thing I found is that the size of land on Mars is about the same as the size of land on Earth. Because Earth has oceans, Mars doesn't. They just happen to have about the same or similar size of land on 2 planets. Now, on the surface is shaped by meteorites, obviously, but also strong winds, volcanic activities in the past, and flowing water and on and below the surface in the past. There were probably volcanic activities and may still have some volcanic activity below the planet right now. The interesting thing, of course, is there is a traffic jam on Mars now. Not only we have 5 rovers, Perseverance being the last one, we have a Ingenuity helicopter, and then the Chinese rover recently landed, Zhurong. And we, of course, have before that several landers, 3, 4 landers on Mars. I think Vikings 1 and 2, if I remember correctly, Phoenix, and so forth. So there have been lots of robotic life on Mars as we speak today. Mars atmosphere is very thin, as we have observed in the difficulty of the or the challenges that helicopter Ingenuity faced. It's mostly carbon dioxide, and they are trying to create oxygen from that, but has a very dynamic weather system. So there is no lack of weather forecasting for Mars, mostly dust storms though. And I was told that Ingenuity is not the only helicopter for Mars. There are various companies or institutions working on various gliders, helicopters, planes to fly on the Mars atmosphere. Mars has two moons, probably very difficult, if not impossible, to see using the telescope. Both of them are irregular and potato-shaped, which is going to be common, actually, as you will see in other moons as well. Potato shape is a common shape for moons. They were most likely captured by Mars from the asteroid belt. And one interesting thing about the larger one, the Phobos, is that it is getting closer and closer to Mars and will eventually be torn apart and crash on Mars surface. Probably not in our lifetime, but that is coming down in some fashion. Asteroids, this is the planet that failed to form. People predict that that was 4 times the size of Earth, but failed to form. So there are at least 200 named asteroids or known asteroids, but predictions are that it could be in the billions. Now, you may know Ceres is the largest one, about 900 kilometers or 590 miles, the size from the north to south of United States. It is the first, I shouldn't say first, it is the only dwarf planet named in that region. It actually has some water seeping to the surface, indicating that it may have some oceans under the surface in Ceres. Asteroids are colliding and breaking up quite frequently. There is this near Earth asteroids and programs to track these asteroids, because some of them are quite dangerous because they have the risk of damaging or risk of hitting and damaging Earth. There are 3 groups, all of them starting with A, Amor, Apollo, and Aten, that are particularly being monitored. Some of them have passed recently between Earth and Moon. Unfortunately, some of them we noticed after they passed. So that tells you about our ability of, or the state of technology in monitoring these asteroids. But they do create some potential risk of hitting Earth. And I was actually told that if they are bigger than 60 meters, I guess, they may cause severe damage to Earth if they hit. I may be wrong on that, but Jupiter is the most, in my mind, beautiful planet. It is 2.5 times the size of the total planets combined. So just imagine that. It is huge. It's a gas giant, mostly hydrogen and helium, and has a molten hydrogen and helium in the core. But it is a failed star. In a sense, if it were bigger, it could have become a star. It has everything a star would need, except it is 80 times too small. Now, I did not know this number. If it were 80 times bigger, Jupiter could have been a star. The other thing that I knew, but I didn't know this number, was that it spins so fast that it completes one rotation in 9.9 Earth hours. It's given the size of this thing, that is an extremely fast spin. As a result, it creates a huge, strongest magnetic field, and I'm told it is 10,000 times the strength of Earth's magnetic field. The red spot, the great red spot that you try to observe with your telescope as one of the first things you try to do when you look at Jupiter, is a cyclonic storm. It has been around for a long time, 340 years. Now, one question that I had, why was it lasting so long? And I found that the reason why it has been around for so long is there is no friction. There is almost no surface to slow down this storm, and the storm is continuing. May continue for another century or two, or maybe longer, thanks to not having a proper planetary surface to slow it down. Jupiter has interesting moons. The four of them are famous, obviously, called Galilean moons that you can see with your telescope relatively easily. There are more moons, 79 official, but as I mentioned later on the chart, some Canadian astronomers from British Columbia, University of British Columbia, they found additional 52 recently, and they project that there may be 600 moons around Jupiter. The moons of Galileo, the Io, Europa, Ganymede, and Callisto are the most famous, and I'll talk about them a bit later in the next few charts. Io, the closest Galilean moon, has 400 plus active volcanoes and huge mountains, 100 mountains, and some bigger than Mount Everest. And the reason why it is this color is the atmosphere is made up mostly sulfur dioxide. Probably very unpleasant place to go. Europa, on the other hand, is probably one of the most interesting moon to visit. It is the smoothest moon. In other words, it has almost no mountains. It is the smoothest solar body in the solar system. It is also very young, one of the youngest solar body. Also brightest moon. It has liquid water under the surface and maybe more than all oceans combined. It is also believed that there could be some extraterrestrial life forms, and its atmosphere is similar to Earth in terms of ratio of oxygen and hydrogen. The next one is Ganymede. This is the largest moon in the solar system, even larger than Mercury planet. Oceans are 10 times deeper than Earth, so there's lots of water in Ganymede under the surface. And it has a very large magnetosphere created by the iron core. Now, interesting thing about Ganymede is, the Juno mission. Juno mission is going to have a flyby by the moons of Jupiter. Ganymede flyby is on Monday. So you could watch out, and we may get some interesting pictures from the Juno mission of Ganymede. Interestingly, Juno is going to visit Europa sometime later next year as well. Juno mission has been extended, as you may know, to have some flybys through these moons. Finally, Callisto, beautiful name. It is heavily cratered moon. It is, they say, most heavily cratered moon in the solar system. It also has oceans, liquid water oceans. And they say it is the most suitable place to have a human base to explore the Jupiter system because it is farthest from the radiation effect of Jupiter. I doubt that anybody will do that, but it is probably better than anywhere else in the Jupiter system. Saturn, I'm going to speed up a bit, is the second largest planet. They have, of course, spectacular ring. Again, another first thing you do in observing whether you can see the rings of Saturn. It's a gas giant. What you may not know is that the density of Saturn is so low that if the density of Saturn is so low that if you could manage to put Saturn in water, it would float. It is that light in density. It also spins very fast, similar to Jupiter, about 10.6 Earth days. And one interesting thing I did not know is that it radiates twice the energy that it receives from the sun, thanks to its atmosphere and the makeup of its atmosphere. So it receives energy and emits twice as much from the planet. Moons of Saturn are interesting. Titan is the largest, but some moons are sweet potato shaped, some moons are regular potato, some are meatballs, some even sponge shaped. And the mystery around these things, these moons, is still continuing. There is even a moon called Mimas, which is very similar to the Death Star of Star Wars. Has the same makeup of the Death Star of Star Wars. The rings of Saturn are what you see is the ABC rings, but the largest rings are invisible to the eye. So there are actually more than ABC. There is D, E, F, G, and so forth, and some of them are not visible. Titan is the largest moon. It has a very dense atmosphere, mostly nitrogen. Methane is found in the atmosphere, but it is the only body in the solar system other than Earth that has liquid lakes on the surface. The lake is methane and propane, but nevertheless, the only liquid lake in the solar system other than on Earth is on Titan. And some scientists believe that Titan must be most hospitable solar body for human habitation after Earth. So maybe Elon Musk should be targeting Titan as opposed to Mars. Uranus is the seventh planet from the sun. It also spins very fast. It's a gas giant, hydrogen, helium. The interesting thing about Uranus that I found, which I didn't know, it has a 97-degree tilt. So it actually spins on its side. And 97-degree versus our 20 plus degree, 27 degree. So it is actually spinning on its side. Also, it spins from east to west, similar to Venus. So sun rises on the west, sets on the east. It has several interesting moons and rings. Titania is the largest. Some of the moons are retrograde or moons. In other words, they orbit the planet in the reverse direction of the spin of the planet. Also, it has rings, 13 known rings that were discovered recently, but they cannot be seen through telescope or through human eyes. They are identified through thermal images, so heat-based imaging. Neptune is the 8th planet, the farthest known solar planet, and as you probably know very well, it is the planet discovered by mathematical prediction due to the effect, the changes that it creates on the orbit of the Uranus. It has also interesting moons. The largest one is Triton. Most of them also are retrograde orbits. It has rings, 5 rings, discovered by Voyager. Triton is interesting in the sense that not only it is the largest moon that has a retrograde orbit, but it has geological activity. It has these geysers erupting with nitrogen gas and discovered by Voyager 2 during the flyby. Pluto and Charon, people's favorite bodies, actually, Pluto. When I was learning about astronomy, Pluto was a planet. It was demoted more recently in 2006, thanks to new definition of what a planet is and isn't. One of those criteria was not to cross another planet's orbit. And Pluto happens to cross Neptune's orbit, even though they may never collide. It does cross the orbit. Now, Pluto has, by the way, the picture above is Pluto, and Charon is the largest moon, which is the picture at the bottom. Pluto has nitrogen ice. What you see, the white stuff, the big white stuff is actually nitrogen glacier. One of the largest, if not the largest glacier, nitrogen glacier in the solar system. Charon, and some people call it Charon, or because it actually comes from the Greek goddess, I believe, and called Charon. Charon is half the size of Pluto, but they are called twin dwarf planets. Interestingly, Charon goes above the Pluto, doesn't go around it. It sort of goes around above the Pluto, and they are tidally locked. In other words, if you are on Pluto, you only see one side of Charon. So interesting combination there. There are some other moons, but Charon is the only interesting moon of Pluto. My last chart, the Oort cloud. Oort cloud is beyond the Kuiper belt, and it stretches 4.7 trillion miles. This is where most of the solar system actually is, 0.79 light years long. It was created, estimated to be, by a close encounter between sun and another star during the first 800 million years of the solar system. And this is where our comets come from. The Halley's comet that some of you were lucky to see in 1986 actually resides there or comes from this Oort cloud out there. Currently, Voyager 1 and 2 are 11 billion miles away from us, and they are probably traveling in Oort cloud. So that's the end of my presentation.
Applause. That was very comprehensive.
Well, thank you for that. Yes, I really appreciated it.